Welcome back to another Flipped Friday. Today's topic, linear inequalities. Your purpose? You need to be able to solve and graph linear inequalities. You were taught in elementary school that alligators ate the bigger number. Alligators don't eat the bigger numbers. They eat fish, turtles, birds, not numbers. Say goodbye to Mr. Alligator. It's time for some grown-up math. This is a less than symbol. We read it from left to right. This is a less than or equal to symbol because it has the straight line underneath the symbol. This is a greater than symbol and a greater than or equal to symbol again because it has a line underneath indicating equality. This is the less than symbol. This is the narrow side. This is the greater than side. It's the larger side. We can read this symbol in either direction, and that's an important thing to remember. We can read this inequality from this side, and we read it 5 is less than x. If we read it from the other direction, we say x is greater than 5. Both statements are true. Here's another one. If we read it from this direction, we say x is less than negative 14. If we read it from this side, we say negative 14 is greater than x. So it really depends on what direction you're reading the symbol from. I want you to think about these two inequalities, and we're going to talk about it in class. Which of these two is correct? Here's the big idea. Inequalities are used when there is more than one solution. For example, x is less than 13. X could be 2. 2 is less than 13. But x could also be negative 4. Negative 4 is also less than 13. And x could be negative 208, which is still less than 13. There are many, many examples of solutions for x that could solve this inequality. How many solutions are there for x equals 13? Again, think about this a little bit and be prepared to discuss in class. When graphing inequalities, there are 3 key steps. First, put a circle at the location of the number. In this case, x is greater than negative 3, so we're going to put a circle at negative 3 on the number line. To do the second step, we have to decide whether or not to fill in the circle. Notice the circles are filled in if there's a line under the inequality sign indicating equal. No line in the symbol, no shading of the circle. Looking at the same problem in the second step, if we're going to decide whether to fill this circle in or not, we're going to look at the inequality. There's no line under this symbol, so we do not fill in the circle. We leave it open. Now we're going to look at the third step. We've already put the circle at negative 3, decided that it should stay open. Now we need to decide which way to shade the number line. X is greater than negative 3. All the numbers to the right of negative 3 are greater than negative 3. Any of these numbers are greater than negative 3, so that's why we put the arrow going out towards infinity. We always want to check our answers. All you need to do is substitute a number from the shaded region. In this case, I'll choose the number 1. If I substitute 1 in for x into the original equation, I can check my answer. 1 is greater than negative 3, so I know my shaded region on my graph is correct. Let's try another example. I'm going to isolate the variable by subtracting 7 from both sides of the equation. This gives me 5x is greater than or equal to 5. Using inverse operations, divide both sides by 5. I get x is greater than or equal to 1. Let's graph it. Step 1, put the circle at 1. Step 2, check the inequality. There is an equal sign under the symbol, so that means I have to fill in the circle on the number line. X is greater than 1, so I'm going to shade in all the numbers to the right that are greater than 1 on the number line. Let's check the answer. Starting with the original equation, I can select any number I want. I'm going to choose 4. Substituting in 4 for x, I get 20 plus 7 is greater than or equal to 12. 27 is greater than or equal to 12. 27 is greater than or equal to 12, so my answer checks out. Let's try another equation with decimals this time. We have like terms on the left-hand side of the equation we're going to combine. 5.6p plus 2.7p equals 8.3p. I'm going to isolate the variable by dividing both sides by 8.3. This gives me p is less than or equal to 9.2. Let's graph it. I'm going to estimate where 9.2 is on the number line. Look at my inequality. There is an equal sign, so I'm going to fill in the circle. P is less than 9.2. That means all the numbers to the left need to be shaded. Checking my solution with the original equation. Again, I can choose any number I want, but 0 is a great number to put in. Substituting 0 for p in the equation, I'm left with 0 is less than 76.36. 0 is less than or equal to 76.36, so my answer checks out. Let's look at one more equation. I want you to pay close attention because there's a new and very important rule you're going to see. I'm still going to use my inverse operations to isolate h. I'm going to add 13 to both sides of the equation. This gives me negative 4h is greater than or equal to 20. Using inverse operations, I'm going to divide both sides by negative 4. This is the important new rule. When you multiply or divide by a negative sign, you must flip the sign of the inequality. Since I divided both sides by negative 4, my new inequality is h is less than or equal to negative 5. Now I'm going to graph my solution. Again, step 1, put a circle at negative 5. Step 2, look to see if there's an equal sign in the inequality. Here there is, so I'm going to fill in the circle. Step 3, make a line to the left because it is less than negative 5. Now I'm going to check my answer. I'm going to select any number that I know is less than negative 5. Plug it into the original equation. In this case, I'm going to substitute in negative 100. This gives me negative 13 plus 400 is greater than or equal to 7. 387 greater than equal to 7. 387 is greater than or equal to 7, so my answer checks out. Please notice that that negative 4 times a negative 100 gave me a positive 400. Here's something else I want you to think about for class. Why do we have to flip the sign when multiplying or dividing by a negative number? Let's try another equation. This one's a little different because I need to combine like terms first on the right-hand side of the equation. Combining 9w minus 3w gives me 2w minus 10 is less than 6w plus 34. I'm going to use inverse operations and subtract 2w from both sides. I'm choosing the 2w because 2 is smaller than the 6 when I'm comparing the coefficients. This gives me negative 10 is less than 4w plus 34. I'm going to subtract 34 from both sides of the equation. This gives me negative 44 is less than 4w. Divide both sides by the 4. This gives me negative 11 is less than w. Here's a new tip. If you rewrite the equation with the variable on the left-hand side, the arrow will always point the direction that you shade the number line. Notice I flipped the W on the other side of the equation, the inequality, and the inequality symbol flipped as well. Let's graph. Step 1, put a circle at -11. Step 2, check the inequality. Is there a line underneath? No, there's not, so I won't shade the circle. Step 3, shade the side of the circle that's greater than -11. Let's check my solution. Starting with the original equation, I'm going to substitute in any number I want to the right. Again, I always like to plug in 0. If I put 0 in for W, everything drops out except the -10 less than 34. Is -10 less than 34? Yes, it is. So my answer checks out. Last one. First, I'm going to distribute the -9 to the C and the -9 to the -3. This gives me -9 plus 27 is greater than -29 minus 2C. Adding 2C to both sides of the equation, I get -7 plus 27 is greater than -29. Isolating the variable, I'm going to subtract 27 from both sides of the equation. This gives me -7C is greater than -56. Now I'll divide both sides by -7. Watch out, this is an important thing. I have to flip the sign again because I divided by -7. So C is less than 8. Let's graph. First, I put a circle at 8. Check the sign. There's no equal sign under the inequality, so I leave the circle empty. C is less than 8. Notice C is on the left side of the equation, so the arrow points the direction I'm shading. All the numbers to the left of 8 are less than 8. Now let's check our answer. Choosing any number to put into the equation, again, I like the number 0. Putting 0 in for C, I get 9 times -3 is less than 29. Is -27 less than 29? Yes. -27 is less than 29. My answer checks out. Now it's your turn. Try these problems for class tomorrow. Solve, graph, and verify your answer. Remember to solve as usual, but make sure flip the sign when you multiply or divide by a negative number. Here they are. Good luck, and we'll see you tomorrow.